Hello, welcome to the brand new section of this course, Python Integration. Let's have an overview of this section. We'll begin with creating a client, then get insight of managing indices. After that, we will begin managing mappings, then look at managing documents. Next, we'll be executing a standard search, and finally, executing a search with aggregations. So let's start with the first video of this section, which is creating a client. In this video, we'll see how to instantiate a client with varying options. The official Elasticsearch clients are designed to manage a lot of issues that typically are required to create solid REST clients, such as retry if there are network issues, auto-discovery of those nodes of the cluster, and data conversions for communicating on the HTTP layer. You need an up-and-running Elasticsearch installation, as we have already seen downloading and installing Elasticsearch earlier. With this, you need Python distribution installed in your system. You need to download it and install in your system. To manage Python, PIP packages must be also installed, and we will install it using getpip.py file. So now it is installed. Full code is available here. Now for creating a client, we will perform these steps. First, before using the Python client, we need to install it, possibly in a Python virtual environment. The client is officially hosted on PyPI, and it's easy to install with the pip command like this. The standard installation only provides the HTTP protocol. If you need to use the request library for HTTP communication, you need to install it using pip install requests. After having installed the package, we can instantiate the client. It resides in the Python Elasticsearch package, and it must be imported to instantiate the client. Import Elasticsearch. If you don't pass arguments to the Elasticsearch class, it instantiates a client that connects to the local host and port 9200 ES Elasticsearch. If your cluster is composed of more than one node, you can pass the list of nodes as a round-robin connection between them and distribute the HTTP load. Localhost 9200, localhost 9200. Often, the complete topology of the cluster is unknown. If you know at least one node IP, you can use the sniff on start true option. This option activates the client's ability to detect other nodes in the cluster. Elasticsearch.elasticsearch localhost 9200.sniff on start true. Now the default transport URL lib3 HTTP connection, but if you want to use the HTTP request transport, you need to override the connection class passing requests HTTP connection using this command. Let's see in detail. To communicate with Elasticsearch cluster, a client is required. The client manages all communication layers from your application to an Elasticsearch server using the HTTP REST calls. The Elasticsearch Python client allows using one of the library implementations. First is the URL lib3, which is the default implementation provided by the Elasticsearch Python driver. Next is requests. This library is one of the most used libraries to perform HTTP requests in Python. The Elasticsearch Python client requires a server to connect to. If not defined, it tries to use one on the local machine that is localhost. You have more than one node, you can pass a list of servers to connect to. To improve the list of available nodes, it is possible to set the client to auto-discover new nodes. I suggest using this feature because it is common to have a cluster with a lot of nodes and you need to shut down some of them for maintenance. The options that can be passed to the client to control discovery will be shown now. First one, sniff on start. The default value is false, which allows obtaining the list of nodes from the cluster at startup time. Next is sniffer timeout. The default value is none. It is the number of seconds between the automatic sniffing of the cluster nodes. Another option we have is sniff on connection fail. The default value is false, which controls if a connection failure triggers a sniff of cluster nodes. Now the default client configuration uses the HTTP protocol via the URL lib3 library. If you want to use other transport protocols, you need to pass the type of the transport class to the transport class variable. The current implemented classes are of two types. First is transport. This is a default value, that is, a wrapper around EuroLib3 HTTP connection that uses HTTP, usually on port 9200. And the other is RequestsHttpConnection. This is an alternative to EuroLib3 HTTP connection based on requests library. Now the official documentation about the Python Elasticsearch client available at this link. It provides a more detailed explanation of the several options available to initialize the client.